Okay, we got the files for visualizing the normal modes. Next, we're going to load it into VMD. First, make sure you have VMD installed on your computer. And once you have that, you can load the structure file first into the VMD and visualize this equilibrium structure. So we just type VMD CO2.pdb. That will launch VMD for us, and you will be able to see two windows by VMD. So one window is for visualization. The other window is for controlling. And from this control window, we can change the representation of the molecule. By default, everything is loaded and presented as a line, but it's not like a molecule. We want the ball and stick type of representation. So we just go to graphics representation, and you will see a new small window for graphics representation. You can change it to dynamic bonds. This is useful when we visualize some bond that changes its length. So we want to make it thinner. And then also create the representation for van der Waals spheres, such that we can see how the spheres changes as the molecules do the vibration. And another thing we want to change is the color. So right now, the carbon atom is cyan. That is not the correct color for carbon if you're going to generate a publication quality figure. So we want to change it to some color that more related to carbon. So let's go to graphics color. We will see the color control window and change it by name. Make sure what you change matches what you select there for the representation. So we are coloring the atoms and the bonds by the name. So we want to select name and we select carbon. We change carbon to gray. Now it looks more like a carbon. But the new problem is that the gray color and the black background has little contrast. So we can change the display background to white to make it easier to see the carbon atom. All right, and then we can go ahead and do the normal mode visualization for this carbon dioxide molecule. So we go to extension, analysis, normal mode wizard. You will see a new window, and there you will see load NMD file, and you can load the CO2.NMD file you generated from here. Just click load NMD file. You will see a new small window that has the CO2 there and NMD there, and you open it. And once you load it, you will be able to see a new small window called NM with CO2. And at the same time, you will see the changes in the display that you got two huge arrows to indicate the normal mode. They point to opposite direction. They have the same length, indicating that this is a symmetric stretch. So normal mode 1 corresponds to the symmetrical stretch along the OCO bond direction. But the problem is that the arrows are so huge. If you want to make a figure for your publication, I guess you don't want it to look like this. And you can change it by clicking on this options for mode, and you click options and you can change the arrow cylinder radius and also change the arrow radius, and also change the arrow length. This is better. And next, we want to make the animation. To make the animation, we first want to adjust the RMSD. So the RMSD means how much you want this to display when you visualize the animation. And right now, by default, it's 2 angstrom. That's too big. If we choose that, you can imagine that these two oxygen atoms will stretch too much, and even worse, they will compress too much and go across the carbon atom. So we want to change this to some more physical values. So you just decrease it. So usually I find 0.2 give us a reasonable amount of stretch and compression of the bonds. So I just choose 0.2 and then make animation, make. And you will see that in this main control window, it just created a new molecule called CO2 mode 1 animation. And it's running, but we can see nothing there. We first stop it. Why can't we see anything there? Because that for this normal mode animation, it's by default displays with the tube drawing method. That doesn't show anything. And we want it to be displaced as ball and stick, just as an equilibrium structure. So how do we fix it? So first, you can manually fix it here, but there's another way. So I will go to extension, visualization, clone representation. And I will get a new small window that allow me to clone the representation from the original equilibrium structure to the current animation of the normal mode. And I click clone. And oh, you will see that this animation overlap with the original structure. So we can turn off the display of the original structure. This is very easy to do. Just go to a control window, and this D letter indicate whether that molecule is visible. So I just double click on it. So when it's red, it's not visible. I just turned off the original structure. And then I can also turn off the two arrows if we don't want to see it to overlap with our animation. And now we can re-visualize this. Click on this mode 1 animation and click play. While it's stretching and compressing, stretching and compressing. It is a symmetric stretch. And you can repeat this for your normal mode number 2. Once again, you get huge arrows, and you can fix that by selecting this copy setting from mode 1, copy, and then the arrows are smaller. And once again, you cannot see the animation. So let's first decrease the RMSD to 0.2 and generate the animation for mode 2. And stop it and clone the representation from molecule number 0, that's the original equilibrium structure, to mode 2 animation. This will give us the structure. And once again, we want to turn off the things, turn off the display of the other things we don't want to see. Turn off, turn off. And now let's just focus on this mode 2 and click on it, run the animation. See, it is doing the anti-symmetric stretching and compressing. And guess what is not mode number 3? So 3 and 4 should be like bending. can just repeat everything, reduce the animation, RMSD to 0.2, make the animation, but we want to pause it and then close the representation, make sure we can see it, turn off the things we don't want to see. So in this case, we can see all these are the normal mode arrows. So it is like this. So it's a bending in this direction. So the blue indicates Z. So it's bending. It's bending in the Z direction. So the CO2 is in the let's see, this is XZ plane. The CO2 is in the XZ plane and it's bending in the Z direction. So we can turn off the arrow and just play the animation. So it's bending. And number 4, I will skip it because it's also bending. But you can do it by yourself. And that's it. And last suggestion, don't waste all your efforts. If you want to save these animations for later use, you can just click on one of these animations and then right click. And once you see this menu, you select save coordinates. That will allow you to save the coordinates. You will see the save trajectory, save data from this mode 1 animation to, you can select any type of file you'd like to. Like you can save it as XYZ or PDB. And you just save and enter some path in a new window, and then you can save it. And that's it. I hope you have learned something useful for your study and your research.